This is Dave Nielsen, head track and field coach at Idaho State University. This presentation is about pole vault box collars. Safety is a primary concern in the pole vault, as we all know. Any responsible coach or institution or organization sponsoring the event knows that safety is a must. Education is the primary goal or the primary tool for providing a safe environment. However, equipment is also a part of this issue. Jan Johnson has served as our safety expert for many years. He's studied the pole vault and catastrophic injuries extensively. Using this data, and since 2003, he's come up with a little graph showing a pole vault pit and where these catastrophic injuries occurred. The next segment will be his own graph so that you can take a look at how this shakes out. As you can see by this diagram, and I'll flash it up there again, most of the accidents, the catastrophic incidents, occurred in the box area. More than 15 in there, where there were 2 off the back and 1 on the side, and that's since 2003. At that time, we'd increased the size of the pit, the depth of the pit, and put some standards on the width of the pit as well. And it took care of some of those other issues. Less off the back, less off the side, but the problem area was the pole vault box. Since the 60s, when we started having poles that would bend, vaulters have been trying to manage the box itself, because the old style boxes had straight up and down walls and a straight up and down back. This inhibited the bend of the pole. As a result, we have had changed rules so the boxes are opened up and the sides of the box are angled outward and the back is angled backwards. That way, the bending of the pole isn't impeded by the box itself. Well, what this has done is by shaping the box a little differently in this manner, it has increased the surface area of the box itself by about 25% or 160 some square inches. Okay, so that's surface area that maybe could be protected. So the premise of building a protective box would be to maybe go back to that size, and that's, I think, where Jan has gone with this. I decided to try that out for my gang to see what kind of an effect they would have on them. And so I'm going to share with you at this time what I've done. This is the box collar that I built. And the basic design here is to create a base, and so to anchor this in, and I have a half-inch sheet of plywood that's cut out right around where the box goes, and it's dimensions of 3 feet across and 4 feet long. Then I glued the padding surface, which I'll talk about in a minute, on top of this sheet of plywood. To anchor this so it doesn't turn around, slip around, I put a couple carriage bolts. You can see them here, a couple carriage bolts in here, about 3 inches from the back stop board and 3 inches from the back edge of the end of the collar. So, and what's done with this is holes are drilled in the concrete around where the box is set, about 2 inches deep, and just place this over the side or down through these holes in the concrete, and this box collar won't move. To use as a cushion on top of the box collar, and the most critical part is looking all over for some kind of material that would provide some cushioning, but would dampen the blow, as opposed to be too hard or just too soft so you'd hit the bottom very easily. We just had our football turf replaced indoors, and this, I guess it's a neoprene type of matting, is a matting that goes underneath the artificial football turf. And its nature is kind of like a memory foam. You push into it and it does not bounce right back. It kind of catches and softens the blow. It's not designed to spring back. We're testing this, and what I did on the box collar is I glued this on with contact cement, and 3 layers thick, so or a little less than 3 inches thick, and it might need actually 4, but we've gone with 3, and that does provide a considerable cushioning. The other thing we thought about doing, and we are testing in the physics or engineering lab, is this, I guess it's like a gymnastics ethafoam, and this is common in packing material, and I'm not sure, I don't think it's that expensive, but that could be put on as well, and we're just testing to see what kind of a result we get as far as a dropper and impact test using this material as well. This might be even easier to work with. After using the contact cement to glue all 3 layers of this foam together and then onto the to the base board, then we put some vinyl over the top. I chose red, kind of as a warning track, if you will. I don't know, it seemed to stand out a little bit better, and it protects the foam itself from the elements. As the foam was cut, it was cut so that it would extend actually into the box area. So this is a kind of a softer cushion in here, but it bends around the box slightly. This area at the back, about 2 inches wide, allows the pole to bend forwards into the back of the box here and then turn to the side as poles do. And you'll see a clip on that in a minute. We'll take a look at the use of the box collar and how effective it was. We used it, I introduced it the day we had an inter-squad competition. We had a little fall inter-squad meet, and a number of people jumping. No one had a problem with it. We took some video of the pole bending actually in the box, some close-up video, and I think you'll see that the box collar functioned as it should. Unfortunately, we didn't have anybody fall short and use it that way, but as far as bending the pole, it didn't impede the pole. So here are a couple clips of the pole bending in the box.
Yeah.
Oh my God! Suddenly developed. It just started coming off.
An amazing 4 till 11
As a wrap-up to this video, this was just my attempt to duplicate something that Jan Johnson did with a couple of little variations that I had that I thought were appropriate. This is not a final product, this is a prototype. The goal of this video is to provide you with some information so you better understand what's going on. I think this is a very good move for increasing pole vault safety. So I hope you enjoyed it.